Yo, what is up, YouTube? Welcome back and happy Friday. My name is Alicia and I'm super excited for this video. Like, smiling from ear to ear already. There's so much to announce, so much to talk about, and I'm gonna switch up how this challenge has been going, and I hope you're ready for it. So, first and foremost, where do we start? Okay, let's start off with the announcement. So cool, guys, this has blown up so much traction over the internet. Like, I don't think you all truly grasp how much attention this is getting. There's thousands of you taking this thing seriously, and it's super exciting. We were able to secure 50 Azure certifications. So that means at the end of this, those of you who are interested in learning Azure Cloud as well will have the opportunity to go and get certified. Now, I know what you're thinking. Alicia, we've been using AWS. How am I going to go get Azure certified? Well, in the month of February, I'm going to be dropping one video every week, taking an AWS project that we built out and doing it in Azure. So replicating it using Azure resources. So in February, you'll have the opportunity to continue learning with the AWS content that we're pushing out for week 3 and week 4. And then you'll also have the opportunity to go through and do these same projects again in Azure. So super exciting, right? Now, to make this even better, because I know we started a little late with this, we are all going to do this together. Like, all 50 of us are going to go out and get this certification. I'll probably do a completely separate video talking about the different Azure certifications and how you could approach which one you want to study for. But in the month of March, once a week, sorry, I had to get my month right. So February, we're dropping all the Azure videos. You should have at least 4 of them. In March, once a week, I'm going to go live with you all and we're going to study together. We're going to watch live YouTube videos, watch trainings, go through some sample questions. Once I figure out kind of what the majority is going afterwards, as far as the certification, we can figure out what that looks like specifically and what day that is. But I would just say make sure that you're plugged into the Cozy Cloud Discord. Make sure that you're following all of us on LinkedIn, because that's where we'll be dropping all of our updates at. So those are 2 places that you want to make sure that you stay plugged in. And obviously make sure you subscribe here, because I'll be dropping more content around it. But super excited to help 50 of you all get certified. I'm even going to take a certification with you all. And yeah, it just really warms my heart that there are so many people invested into making sure that you guys have the resources to go out and win big. So W's in the chat, W's in the chat. That's a big win. Okay, cool. Now let's get to the nitty gritty of what we are here to do today. Guys, like I said, there's a wide variety of experience participating in this challenge. We have some people where this is their first time doing any of this. And shout out to you all for jumping straight into the deep end and learning a lot about scripting, Python, Dockers, all these AWS resources, and just hanging in there and giving yourself grace to learn. Like, applaud yourself, because this is not easy stuff at all, but it's well worth it once you get a level of mastery. And then on another hand, we have some guys and gals who have been here before. You've been doing this for a while, some individuals who have been doing this for a while. And I want to make sure that you all are getting properly challenged also. So this one has really 2 different directions you can go. What I did, actually, let's just get straight into the computer and talk about it. Okay, so let's jump into it, right? So essentially what we have here in this diagram, right? And we kind of already did this like locally with our container, but we have our Docker container that we built, tagged, and pretty much has like that image of what we want to run and what our app is going to look like. So that's what we call our application layer. Now, the beautiful thing about Terraform is it can handle configuring our infrastructure for us. And one of the reasons why we use Terraform to do this instead of like the Python scripts is because Terraform is a declarative language by nature. And so what that means is that essentially, as we're having to change things about our infrastructure layer, we can use Terraform to, 1, standardize that, have consistency as we scale. And then also, like, it doesn't really care about like what, basically, like, you can tell Terraform, this is exactly what I want, do what you have to do to get there, right? So like if we were running this on, let's say like 3 servers or whatever, as an example, and then we decided like, hey, we need to go from 3 servers to 8 servers. Terraform is going to do, it's going to assess the environment. What is our current state? What do we currently have? What are you interested in configuring? And so basically it's going to say, okay, how can I go out and create 5 more servers? So a lot of upside there, as opposed to like when we're using these scripts that we've been doing in this project, we're really only interested in like a small application, right? It's not like a production level. So it's easy to cook up one quick script, but imagine having to edit that like 5 more times manually. It just becomes excessive to keep up with. So that's why we're introducing Terraform here. There's like a wide layer of like there's a wide variety of what you can do with Terraform. I mean, some of the same technology that we have with Git as far as version control, like you being able to pull out information, make changes, and then commit it back to a repository. You have that same level of version control with Terraform also. I won't get into the weeds of that because that's not the purpose of this video, but I really just, when you think about Terraform, I want you to think about like scalability and the ability to work with others on the team and not start to overstep each other as you're making changes, which is awesome. But anyway, so we have our Docker container, right? So remember what that container has is all of our scripts that, goes and gets the data from the API. Then it's going to return it as a JSON format, right? So JSON is just going to be basically a bunch of words or strings that isn't actually videos. It's really just text. And then so from that, we convert one video, we extract out a URL, we go to that website and we download it. And then we save that in our S3 bucket as well. And then we use AWS Elemental Media Convert to enhance that image, right? That is where we go and change the audio specs and all that good stuff, right? This is the process that has happened so far. We've done all this locally with building our container. Now we're going to take this one step forward and show you all how to do it using Terraform to build out some of those resources. So we're going to pick up exactly where we left off 2 days ago. Scroll all the way down to the bottom to the Terraform bonus part, right? So let's go over some of the files that we have. The first one that you're going to have to look into is this VPC setup.sh file, right? And this is located in the NCAA game highlights repo underneath of the Terraform. Sorry, I lied. It's in the NCAA highlights repo underneath of resources, which should just be on this tab. Okay, great. So VPC underscore setup sh. Now, this isn't intended to be like a networking and infrastructure segment. So I won't go into the weeds of that and confuse some of the beginners that are following along with us. But essentially, the reason why we need to set up this VPC, these private subnets, these public subnets, is because our application is doing 2 different things, right? A piece of our application is going out and talking to the internet to get the API, to go to the URL. So we need outward internet access. But then another piece of our application is talking to things internally like AWS Secrets Manage, right? And that requires private connection and private communication. So this script essentially has all of the right things. So that way, when we need to talk to the public, we can communicate in that nature. And then when we need to talk to private or internal resources, we can communicate in that nature also. Now, this is where some of the variation starts. This is your challenge. You can approach this how you see fit. For those of you who are looking to take that next step and you really want to stretch yourself and, all of this stuff isn't new to you, your first optional task is going to be adding in this VPC setup to the Terraform scripts itself. So automating the creation of this inside the Terraform scripts. I left this as an outside entity for those of you who are beginners. If you just want to understand the setup and how things are supposed to talk, you can look at this script and try to kind of use that as a learning method to look backwards as to why I set it up this way, right? So your challenge, approach it how you see fit. But we're going to take those contents, create a file that says VPC underscore setup.sh, and then run bash. And you'll see an output at the bottom that has like your internet gateway. Let's go to that repo. It'll have your internet gateway, your private subnet, your public subnet, all of the information that needs to go in here through line 8 through 13 will be put on that output. Your public route table and your private route table will live there. Now, since we're kind of jumping around and we're already in this file, let's just talk about it. The Terraform.tf vars file is going to be a space where we actually go out and save all of our variables that are being called. So this is like the .env file equivalent of what we were working on when we did the local build the first time, right? So as you'll see in here, the first top part, we're going to leave this as is, especially for my beginners. Just leave this just so you won't run into any issues. You shouldn't if you change it, maybe the region. You shouldn't run into any issues if you change any of these names, but just want to make sure that it's as simple as for you. Just run it the first time through with this, and then maybe go back and swap it out. Now, this rapid API underscore SSM parameter.arm or ARN. This is where instead of hard coding our API key, we actually are going to put our API key in a secrets manager on AWS, and this is what's going to pull it. So once you complete that step, you'll just have to swap out these X's with your AWS account ID, right? And so that's the next step here. If you run this script locally, you'll just paste in your key here. This is going to then store that API key at this path. So underneath of my project rapid API key, this value will be stored as a secure string. And then we will pass that in through our environment variables file here. Now the next step is we're going to want to describe our media endpoint, media convert endpoint. We did this when we had to run this locally. So you can copy and paste that over, or if not, you can run this command and put it in here. This is another thing. Once again, all of this can be automated. I like partially set you up for success with some automation on Terraform, but also left some wiggle room for you to approach this. So if you want to take on the challenge of making your own modifications, I would say start off with some of the simpler things like the parameter key or this endpoint here for the media convert. Start out there first. This one is going to be a little bit more challenging because you have to understand what requires public access and what requires private access. But I think these two are some beginner-friendly challenges to start with. So you'll paste in your media URL there. And last but not least, we have this media convert role underscore ARN. We're actually leaving this empty. And I wanted to leave it empty to show you guys an example of what your script could look like when you actually want it to go out and pass those variables in from the resources that it's creating. So this is going to go out and create an IAM or an identity access manager role for us. And then it's going to essentially use that or call that value here within these open quotes. So that is in a nutshell Terraform.tf vars. The only other worthwhile thing I want to note there is that you want to make sure you add that to the git ignore. Well, it's in the git ignore, but if you were building this project out on your own, you will also want to attach that to the git ignore so that way you're not committing that to your repo. In an ideal production state, this just has these types of open quotes so that way you're not hard coding anything anyways. But some of the things like these names you might have to put in and call within there, right? So let's move on to the top of the list and kind of work our way down. That's the variables. It really drives everything. What you'll see now is that within all of our other scripts, we are just calling those variables. Nothing is like hard coded in. And so it makes it easier to update, right? Like think about all these places we call like AWS region. And if we wanted to change a region, we have to go in and individually swap that so many times within these files, within our infrastructure and within our application. Now with using these variables, we just swap it out in one spot and it saves us a lot of headache and time. So what this container definitions.tpl file does is it's actually going to define the container specifications for our ECS task. So it's going to utilize Terraform's template file function to dynamically generate JSON formatted container definitions based on our input variables themselves, right? So you'll see things like your environment, your bucket name, the media convert endpoint, the ARN that we set up, and the rapid API key, all kind of pulling in there from that variables terraform.tf vars file that we had set up. So moving on to our ecr.tf file, This is a really quick read. This is going to manage the resources related to Amazon Elastic Container Registry, or ECR, which is what's going to store those Docker container images that we push up. Moving on to our ECS .tf file. This one is going to handle all resources related to Amazon Elastic Container Service, ECS. It's going to include the clusters, the services, and the task definitions themselves. And so with that being said, the ECS cluster is going to define that you will host your services in tasks there. That task definition is going to specify the Docker image, resource allocations, network settings, and container configurations themselves. You'll see some things like CPU and memory in there. One of the cool things about this is, like, if you go in the URL and you click on the task definition, or you would try to like create this within the UI itself, not the URL, the UI, you would see that like these same options are in there, like for as far as like compatibility, CPU, memory, and all of that good stuff. It also ensures that you have certain dependencies, right? If you need things like load balancers on a production like application, this is where you could house that. Essentially what a load balancer does is it ensures that like everyone's having a smooth experience, no matter how many people are accessing the application. So it's a way to kind of redirect people to different pieces of the infrastructure, so that way the traffic is not flooded. So think about it like this: like if it's the day of a shoe release, the website typically crashes because there's so many people flooding. Load balancer, auto scale, things like that are in place to essentially make sure that like there's a seamless experience across the cloud when there's high volume. But then the next day, when like maybe they have their regular traffic, scale back down to cut down on the costs. So load balancing isn't doing the scaling part, but it is kind of directing with those resources that you have on your infrastructure where that traffic is going to. So this is some of the DevOps terms. I want to like start to introduce you guys to things, because I feel like you're at the point now where like certain things are going to start to stick. Like the first time you hear this now, it might sound like a lot, but then you'll watch another video and it'll be like, oh, okay, like I remember Alicia saying X, Y, and Z. But these files are luckily named based on what they do, so it's a little bit easier to follow along. But the im.tf file, you guessed it, it manages our identity and access management, or our IAM resources. So that's going to include our roles and policies that are required by ECS tasks and other AWS services that we're using in here, like Media Convert. Now, that is another spoiler alert or thing that I have hidden. No, I'll wait on that one, actually. I'll show you guys once we get there. But yeah, it's going to define the roles that those ECS tasks and Media Convert jobs assume to access the AWS services in a secure manner. Remember, we want to use our least privileged model. So if you want to go through this, and somewhere where you'll see asterisks to access resources, right? Like there is a spot in here where we're pulling the secrets ARN. There's a spot in here where like we're using some asterisks. If you want to update this to granularly specify one specific folder or path, go and implement that, and you can talk about how you increase the security kind of this script. That's like the rule of least privilege access. Next up, we have our main.tf file, and this is going to serve as an entry point for your Terraform configuration and setting up providers in global settings also. So this is going to specify the required Terraform version and providers in the Terraform block up here. And then in the provider block, that's where we're going to configure the AWS provider with that specified region. Now, what you'll see down here is that you can also use S3 to configure a backend block also. And essentially what that does is you can start to store your Terraform state buckets in S3. And what your state bucket basically does is, like, every time you run a Terraform script, for lack of better words, it saves a snapshot of what that environment looks like right now, right? So going back to the example that we used earlier, we created 3 servers. That would be saved in our state, right? what IAM policies were created, how many servers, all of that good stuff is saved there, right? Then we come back and say, okay, we want to scale up from 3 servers to 8 servers. It's going to go back and look at that configuration file and say, okay, we want 8 now, we have 3, I need to create 5 more, and then it gets it done. There are some data sources in here also with the AWS caller identity. That essentially is going to retrieve details about the current AWS account, and it'll be useful when we're constructing some of the ARNs, like how we left that one string open with the open quotes. That'll just be able to fill in that information there. So the outputs file is essentially what we see after the entire script runs. So I think this is in alphabetical order, not like chronological order. So that's kind of why we're dancing all over the place. But what our outputs file does is it's going to give us a description and a value for what information is being exposed. So after we run this, we'll know exactly what is the name of our S3 bucket, what is the ECR repository URL, what is the ECS cluster name, what is the ECS server name, and what is the media role ARN. So this will be convenient for us if, we're doing this across, think about it, multiple resources. Right now, we're just creating one bucket, but imagine having like 20 of them, right? You might want to know the names of them. So it applies that in the output for us. The S3 bucket is going to manage the Amazon Simple Storage Service, or S3 resources, primarily used for storing and retrieving the data itself. So this is going to define an S3 bucket with a name sourced from those Terraform variables. And then if we had an option, we could add in like tags to pretty much like sort out our metadata. There is also an option for versioning with your S3 bucket, which is, I think, pretty useful if you want to uncomment this code out and work with that. Versioning on the S3 bucket is convenient because think about it. As you run different queries or as you run different scripts that interact with the same container, you can see the version of that. So you might go through this and only get one video, but then go back and tweak the application code or tweak the script so that way you're getting all of the videos with the URL, right? And so you can see that version of like, okay, this is what it was when we had one video in it. This is what it is now that we have like 20 or whatever. So that is pretty cool and an optional thing, right? So that's why I said it's a lot of optional things in here to make it as advanced as you want it to be and to dive into whatever is of most interest to you. And I'm trying to explain the complexities of each challenge so that way you kind of know what you're taking on as you march down that path. But our security.tf file is going to handle our security groups and other security related configurations. It's going to control all of our inbound and outbound traffic for your AWS resources themselves. So this is kind of just placed here more so as a hint for if you want to take on that initiative of not hard coding in the VPC and the subnets and all of that. You can use this block here to sort of build from there. So I won't say too much on this since it's really up to the networking folks, like which port you want to use for the traffic to flow on and all of that stuff, which is a whole boot camp within itself. But we are on the tail end. We already went through our Terraform TF vars file, so we will skip that for now. Last but not least, variables.tf. This is going to define all the input variables that are used in your Terraform configuration, specifying their names, types, and descriptions. So this defines them, but the file above it actually has the inputs that are injected into them. So I wanted to make that distinction so you all are not confused. But we have went through all of the files, so let's jump into the fun stuff where we actually bring this thing to life and make this happen, right? So the first thing you want to do is you want to make sure that you are in the correct directory of where the Terraform scripts are filed. So you'll use CD to do that. If you need to list out where you are, you can use LS. It'll show you, what's in there, all the files. If you're in the source folder, you should see all of the application scripts like runall.py and all of that, the Docker file. If you do CD to Terraform, you will be in the right spot. Now, the first thing we want to do is we want to run Terraform initialize. So let's go ahead and jump into it with the Terraform initialize portion of it, which is our first step. So essentially what this is going to do is it initializes our Terraform working directory. What does that mean? It's going to download whatever required plugins we have from our provider. In this case, we're using AWS, but it could be Azure, Google Cloud. It's also going to configure the backend itself. So like that S3 or local storage for that Terraform state file that we said that gets created after we actually apply these things. And then it's going to prepare the directory for the following commands like Terraform, plan, and apply, which we'll get into. You typically use this, or not even typically, you use this whenever it's your first time you run a Terraform in a directory, or after you add or change any of the providers in your current configuration file. So if you were taking this and moving it over to a different provider, or after pulling a Terraform project from version control itself. So since this is our first time in a directory and we are pulling this from a version control, we are for sure going to want to start off there, right? And you should get an output that says success. Now, the next thing that we want to do after we initialize is we are going to use Terraform validate, right? Which is going to check the validity of our configuration Terraform files. So this is going to check all the .tia files for any syntax errors or issues. It's going to verify that resources, modules, and providers are configured correctly. And it's going to ensure that the configurations conform to any Terraform rules. So you can get errors here, and this is where you can debug and troubleshoot what's going wrong to fix that. So it doesn't verify if the configuration works with your cloud provider or infrastructure. It's just you going to check if you've made any changes to the TF files and ensure the correctness before running them, right? So I want to make that quick distinction that it is just checking for correctness. After we run that, then these are just ran back to back, right? We're going to run Terraform plan. And what Terraform plan is going to do is it's going to create an execution plan showing us what changes Terraform will make. So going back to that example, when we scaled up 3 servers, it's going to say, okay, we had 3 servers, we're creating 8 servers. This is what's going to change within them. You can also confirm like which environment it's going to, like dev, test, in production. Those are like 3 different stages. So dev is typically where, we do all of our local debugging and testing and make sure we can iron out as much as possible. Testing is a different stage or a different environment where our manual testers might go and interact with the application. And this is just to make sure that they catch anything that us as devs didn't, because dev and infrastructure is usually just making sure that this thing works. QA is actually making sure that like the quality is there. It's not buggy. It's not laggy. Icons are missing. Their attention to detail is higher. And then last but not least, production. That's where like our end users sit and interact with this, right? So plan is going to connect to the cloud provider to determine the current state of your infrastructure. It's going to compare that current state with the desired state in your .tf files. And then it's going to output any actions that are required to achieve that desired state. So if it needs to add anything, modify anything, or delete resources, you could kind of think of this as doing a dry run without making any changes, which is very useful. By default, you could run a Terraform plan and it could find the file, but you could also, which I show here on Terraform apply, if you need to specify what the variable file is and you aren't using this configuration, that is how you would do so. So trying to give you guys some variety so you can start to learn like the different tricks and the different approaches to things, right? But last but not least, we have Terraform apply. This is where we are going to apply all the changes that are required to match our new configuration, or in this case, our first time doing it, right? So this is going to provision any updates. It's going to destroy resources in the cloud infrastructure. And it's going to save the updated state to that state file, terraform.tf state. You'll see after you run this for the first time that file will actually appear for you guys. And this is also going to require the user to confirm by manually typing yes in the terminal. You can set up a flag that uses auto approve if that's something that you're interested in. But typically, when you are working like in a production level, you want some gates or checks and balances. But yeah, if you wanted to do the auto apply and auto approve, like mainly like in CI/CD pipelines, after apply, you could just put like how it's a slash here. You could just put /auto/approve, and that would work. So great. We've gotten you to this point now. Now we're circling back to some of the things that we've done on day one. So we just build our highlight pipeline using the latest, and then we're going to tag it. You want to make sure that you're swapping out your account ID and your region. We are using US East 1 there, but swap that out and run that within your terminal. And then the next thing you need to do is log into ECR and push. Now, when we did this build yesterday, remember, we did the build and the push locally. Now, instead of pushing locally, like local Docker, we're actually going to push it into our ECR registry. So we need to authenticate first. If you have some of your environment variables like configured and you're already logged in, you might not need that step, but some people got hung up on that. So I wanted to add that in just to avoid any issues. So once you build it, this is what you will see. Maybe I can actually talk about it now. Let's go over to the S3 bucket while that kicks off. So what I did was I made our S3 buckets two different names. When you went through it on day one, it looked something like this. Our day two bucket is going to say NCAA highlights final. And the reason why I did that is so you can actually compare. Like, it is the same exact thing. It's just two different processes to doing it, or like two different layers that it's happening on. But as you can see here, we have our highlights JSON file that is stored. That's the first leg of what we grab. And then we have our first MP4 video here that was just grabbed literally a couple of hours ago, like an hour ago. All right, cool. So that finally pushed through. And so when we come to our services now, we can see that we have one task pending to run. So when we come over here to our task down here, it'll show that we have one pending. It does take a while to kick things off. Sometimes it can be a little sluggish. But if we come over here to our logs, this is where we'll actually start to output step by step what is going on. So there, we refreshed it. We can see it went and grabbed the highlights from our API. It grabbed them successfully. It saved the highlights to S3. It's confirming that the bucket already exists, so it doesn't need to create it. And we save that JSON file to the highlight. So now it's going to take a little bit more time, but the next leg of it is it's going to, remember, go out to that URL and download it into the first video bucket. So when we come back to our S3 bucket and highlights, we can see that literally just happened. So the next step would be this video one updating. Now, so I guess while we wait for that, I can talk about something else, right? So another kind of wrench that I threw in here for those of you who are interested in taking this challenge to the next level is there is a bug in this code, right? There are two bugs. The first one is that there's an infinite loop somewhere in there. So that means that this thing is going to continually, once it like succeeds, it's going to kick off another run. It's going to build out another container, run through the task definitions like infinitely until you hit your API limit. Now, I wanted to put this in here because, guys, people write bad code all the time, or people write code that makes mistakes all the time, and someone has to catch it and debug it. So there's two routes. For those of you who are beginners and don't want to take the time to figure it out, there is a file in the GitHub repo. There is a file in the GitHub repo in the resources section. It has NCAA project cleanup.sh. If you run this, it will stop everything from running. You'll still be able to see the contents in the S3 bucket, but the load balancers, the security groups, the CloudWatch logs, and the clusters and services in the repo will be deleted and stopped. So that is the perfect way to not have a big build. But for those of you who are interested in debugging, I want you guys to figure out how to stop this from continually creating resources. And the reason why I came up with this is because this is actually a great interview question. Like when people talk about talk to me about a time where you could have saved the company money, or you caught a bug, how did you approach the developer? This is preparing you for that real world scenario right now, right? Now, the second bug that you will see here is that the media convert job is giving us an access denied. There's something wrong with our IAM permissions that we configured that is not allowing us to run the media convert portion of it. Now, I'll give you 2 hints to debug this. 1, check permissions, and 2, also look into potential memory issues that we might be having with our container. That's the only 2 hints I'm going to give you guys. So this does not run the media convert job. If we come over to our jobs and sign in again, and we refresh, we will see that we have not ran a media convert job today. So 2 cool little things that you can participate in to make this challenge yours and take yourself to the next level. Yeah. Okay, and just like that, that concludes our week 2. I hope you guys are enjoying like the variety of challenges that you guys got in this one. I'm excited to see the different directions that you guys go in. Just as a recap, next week will be a week for you guys to get caught up on any documentation, going through some of these resources and learning more wherever you need to fill your gaps. Remember, this is your challenge, so you only know what skill sets you need to develop on. Make a learning plan for that and stick to it. But the following week, right? So February 3rd, I believe, Monday, February 3rd, we are kicking off with infrastructure and automation. So make sure you are subscribed to Shae's channel. She will be kicking us off strong next week. And yeah, guys, I'm so excited for you all. If you all enjoyed the twist of this one, please leave me some feedback in the comments.